Okay, good afternoon, everyone. Yeah, we'll continue from where we stopped the last time, and talk about the principle of availability. Okay, the principle of availability. Data availability is the principle used to describe the need to maintain availability of information systems and services at all times. So, cyber attacks and system failures can prevent access to information systems and services. So, for example, interrupting the availability of the website of a competitor by bringing it down may provide an advantage to its rival. So, this denial of service, which is called DOS, attacks threatening system availability and prevent legitimate users from accessing and using information system when needed. Okay, so there are methods used to ensure availability include system redundancy, system backups, increased system resiliency, equipment maintenance, up-to-date operating systems and software, and plans in place to recover quickly from unforeseen. Okay, so that is one of the okay. So there are methods used to ensure availability include system redundancy, system backups, increased system resiliency, equipment maintenance, okay, then up-to-date operating system and software, and plans in place to recover quick. So these are the methods you can use, okay, to make sure the attack is not carried, okay. So we have the malicious. So let's look at the 5 nines. Let's look at the 5 nines. Okay, 5 nines. So eliminate single points of failure. Provide for reliable crossover and detect failures as they occur. So let's look at the 5 nines. People use various information systems in their day-to-day lives. Computers and information systems control communication, transportation, and the manufacturing of products. So the continuous availability of information system is imperative to modern life. The term high availability describes system design to avoid downtime. So high availability ensures a level of performance for a higher than normal period. Okay, so a high availability system typically include 3 design principles. So what are the 3 design principles? We have the first, eliminate single points of failure. We have the second, which is provide for reliable crossover. And we have the third, detect failures as they occur. All right. So these 3 design principles, okay, are for high availability systems. So the goal is the ability to continue to operate under extreme conditions, such as during an attack. So one of the most popular high availability practices is 5 nines. Okay, the 5 nines refer to 99.999%. So this means that downtime is less than 5.26 minutes per year. Okay, meaning that you have created a system whereby the only downtime you will experience will just happen for just 5 minutes. Okay, it just happened for 5 minutes. Now let's look at this design principle so you can have full understanding of what we're talking about. So we have the first one, which is the standardized systems. Okay, now the goal is to have 99.999% less than 5 minutes downtime per year. So the system standardization provides for systems that use the same components. Parts inventories are easier to maintain, and swapping components during an emergency is possible. That's having a standardized system. Then we have the clustering. Now, the clustering is multiple devices grouped together, okay? Multiple devices grouped together that provide a services that appears to be a single entity to a user. So if one device fails, the other device remain available. So clustering is another good one. Then we have shared components system. Systems are built so that a backup system can totally replace one that failed. Okay, so shared component system is another, 5-9 steps. So how do you ensure availability? How do you ensure availability? This is very important. This is very important as a cybersecurity professional. How do you ensure availability? Now we have about, I think about 7 steps, okay, to achieve this, all right? And the 7 steps is this. Organizations can ensure availability by implementing the following. First, you must have equipment regularly. You must have equipment regularly, okay? The equipment maintenance must be key. And what does that mean? When you talk about the equipment maintenance, you are talking about the regular equipment maintenance can dramatically improve system uptime, okay? So maintenance includes component replacement, cleaning, and alignment. Always make sure your computer is being maintained every time. Don't just leave it like that. That's what they're trying to say. So that's number one. Then OS, operating system and system updates. Operating system and system, modern operating systems, applications and software programs are continually updated. When you have a computer or you have a system in your office, as a cybersecurity person, make sure you update the operating system of those systems, because many of these systems or many of these software they create today always require an operating system to be updated, okay? So you continuously update them to correct errors and eliminate vulnerabilities, okay? So to eliminate vulnerabilities, okay? So all systems, applications, and software should be updated on a regular schedule. So cybersecurity professionals can subscribe to alerts that announces new update system. So as a cybersecurity personnel, make sure you subscribe to many of these new software, new antivirus, and all those things. It helps to keep up. Then you have the backups testing. Backup testing is another way to ensure availability of your system. You back up of organizational data, configuration data, and personal data. Ensure system availability. Okay? It ensures system availability. Okay? It ensures system availability. Okay? So when you have, hold on please.
I think those cars.
Okay, so sorry about that. There was a pause in network. So we had the back we had the we had the backup of organization data, which is very important. Okay, then configuration data and personal data ensure system availability. So backup systems should also be tested to ensure these systems work properly and that data can be recovered in event of data loss. So the third one is backup testing. So the fourth one is disaster planning. So you must have a way of resolving a disaster that comes up at a particular time. So immediately you have that experience, you must have a way, okay, of resolving it. Okay, so a disaster planning is a critical part of increasing. A disaster planning is a critical part of increasing system availability. Okay, so employees and customers should know how to respond to a disaster. It's very important. The cybersecurity team should practice response and test backup systems and be familiar with procedures for restoring critical systems. All right. So plan for disaster is another thing that can ensure availability. Okay. So we have the other one that talks about the new technology implementations. So when you're talking about the new technology, you're talking about how to implement technology. So high availability requires continuous evaluation and testing new technologies. So as a cybersecurity professional, you are also required to use new technology products and devices. So don't be a cybersecurity professional that likes using Windows 97 or like using Windows 2007 or you don't like updating. When everybody is updating to the new Microsoft, you say no, you want to stick to the old one. So as a cybersecurity person, you must make sure every new technology that comes out, you must know and understand that technology. Very, very important. Okay. So then we have what we call the unusual activity monitoring. This is very, very key. This unusual activity monitoring is very, very important. So continuous system monitoring increases system availability. Monitoring event logs, system alerts, and access logs provide the cybersecurity professional with real-time system information. So this information can identify attacks after the event occurs and enable the cybersecurity professional to fend off attacks as they occur. So it is very important that unusual activity monitoring is done. Then we have the last one, which is the system testing. Okay, availability testing. You must always test all the time. All systems should be tested to find vulnerabilities. Always test your system to know that, okay, nothing is coming out of the system. Nothing is happening that is not supposed to happen. Okay, so testing can include port scans, vulnerability scans, and penetration tests as well. All right. So that is how to ensure availability. Okay. So this activity okay. So I expect you guys to go and do this activity. Like I told you, every activity in your class or in your particular chapter is meant to be done. Okay. So how do you do that? You log into your page and do all these things. It's very important because it's going to be showing on your record that you went through the activity. Okay. So everything is connected online. So make sure you do the activity and you submit. Okay. Very, very important. So we move to the next, which is types of data storage. We want to talk about the types of data storage that we have. Okay. I want to talk about the data storage that we have.
Hello, what happened? I can't hear anybody's voice again. Is it network?
Maybe it's the teacher's network. Don't worry, we'll come back.
But it's still online. It's still showing that it's online.
Yes, maybe we'll come back.
Yeah.
Okay, sorry about that. So we're talking about types of storage, data storage, types of data storage. So stored data refers to data at rest. Data at rest means that a typical of storage devices retains the data when no user or process is using it. So a storage devices can be local, okay, on a computer device, meaning you can have an hard drive on a system that is not connected to internet. That is what they mean by on the network, okay? Why a number of options exist for storage data. So we're going to see different types as we proceed in this story, because now why this storage, why the issue of storage had to come as a cybersecurity person, because all the data you see or you use are always stored in a storage device, okay? So the first thing you need to do is, how do you protect the storage device? So you need to identify the types of storage devices that you have to protect, okay? And that is why we're talking about the storage devices. So we have the direct attached storage, which is called DAS. A DAS is storage connected to a computer. So a hard drive or USB flash drive is an example of direct attached storage by default. Systems are not set up to share direct attached storage, meaning you are not connected to a system that is not on internet. So direct access or direct attached storage can only connect from your computer to the hard drive, or from your computer to the USB. That's what they're trying to explain here. So we have another one called redundant array of independent disk. We have another one called redundant array of independent disk, which is called RAID. RAID uses multiple hard drives in an it uses multiple hard drives in an array, okay, which is a method of combining multiple disks so that the operating system sees them as a single disk. In banks, in network organizations, in MTN, Globalcom, all these organizations, what they use is RAID. They use RAID because RAID provides improved performance and fault tolerance. Okay, all right. So the other one we have now, another one we have is called a network attached storage, which is called NAS. NAS is the device, okay, is a storage device that is connected to a network. Is connected to a network that allows storage and retrieval of data from a centralized location by authorized network users. NAS devices are flexible and scalable, meaning administrators can increase the capacity as needed. So we talked about the NAS. Okay, as we go deep into the topic, you see more an expansion of all these devices. So a storage area network architecture, a network-based storage system, which is called SAN. So SAN system connect to the network using high-speed interface, allowing improved performance and the ability to connect multiple servers to a centralized disk storage repository. Okay, so now we've talked about the SAN, we've talked about the NAS, we've talked about the RAID, we've talked about the DAS. Now, the one that everybody knows when you talk about cloud this, cloud that, is the cloud storage. Okay, now cloud storage is a remote storage. That's why they call it cloud, a remote storage option that uses space on a data center provider and is accessible from any computer with internet access. As long as you have internet access, you are accessible to a cloud storage. Now, what are the cloud storage you are looking at? You are looking at Google Drive. We're looking at iCloud on your iPhone or your Apple device. We are looking at the Dropbox. Okay, these are examples of all. These are all examples of cloud storage provider. We have Amazon too. Amazon has their own cloud as well. So most of the people, for security reasons and for the money that a lot of organization is spending, people move to the organizations that have more security on their cloud storage. So what are the challenges? Want to look at the challenges, right? What are the challenges of protecting stored data? Now, you can see the diagram in front of me or in front of you. You can see how these are data storage and see the way, you know, when you go to the telecom companies, this is how you see them, you know, store all the data, all your phone calls, all your this thing goes into a storage. Okay. All right. So organization have a challenging task in trying to protect stored data. In order to improve data storage, organizations can automate and centralize data backups. Okay, so we're going to look at the first one, which is the direct attached storage. Direct attached storage can be one of the most difficult types of data storage to manage and control. Direct attached storage is vulnerable to malicious attacks on the local host. Stored data may also include backup data. So backups can be manual or automatic. So most organizations should limit the types of data stored on direct attached storage. In particular, an organization would not store critical data on a direct attached storage device. Now, the reason for this is because it can crash. And when it crashes, you don't have access. And even if you don't have a good backup, you have a problem. Power is always the biggest problem of direct attached storage. So we have what we call the network storage system, which is the network storage system covers the RAID, covers the SAN, and covers the NAS as well. Okay, so the network storage system offer a more secure option. You can see them telling us that Network storage systems include RAID, SAN, and NAS, provide greater performance and redundancy. So, however, network storage systems are more complicated to configure and manage. They also handle more data, posing a greater risk to the organization if the devices fails, because these devices, these RAID, SAN, and NAS, they use the biggest storage ever to store files. So the unique challenges of network storage systems include the challenges they face is configuring, testing, and monitoring the system. So if you don't have those three things in place, there is possibly be having serious challenges, okay, with challenges with protecting stored data. So now we're going to look at the methods. What are the data in transit? Now we want to look at, we've looked at the storage part, which is the NAS, the RAID, okay, and the SAN. Those are the network. They are not connected to the internet. They are not transmitting. They're just within the network. So now we're going to talk about the methods of transmitting data. What are the methods of transmitting data? What are the methods of transmitting data? Okay. Data transmission involves sending information from one device to another. There are numerous methods to transmit information between devices. Okay, so we're going to look at the methods. We have the sneaker net, we have the wired networks, and we have the wireless network. So the sneaker net uses removable media to physical move data from one computer to another. That's the sneaker net. Okay, uses removable media to physically move data from one computer to another. You know what that means? That's moving an hard drive to another system. Then we have the wired network. This one uses cables to transmit data. That is when you use your LAN cable to connect, to transmit data. So you connect two cables together to transmit data. Then we have the wireless network, which uses radio waves to transmit data. That is your phone, or anything that has to do with wireless. It uses what we call radio waves to transmit data. So organization will never be able to eliminate the use of a sneaker net. Wired networks include copper wired and fiber optics media. Wired networks can serve a local geographical area, which is the LAN. I mentioned it. Local, that's the LAN cable, local area network, or they can span great distances. They can even have wide area network, okay? But when it comes to wireless networks are replacing wired networks, which is what we see today. Wireless networks are becoming faster and able to handle more bandwidth. Wireless networks expand the number of guest users with mobile devices or people with small office home office, that's what they call it, and enterprises network. So both wired and wireless network use what we call packets or data units. Okay, so the term packet refers to a unit of data. That is what we call packet. A unit of data that travels between an origin that is traveling from one place and to a destination on the network. So there are protocols, okay, that govern this movement of this data from one place to another. So we're going to talk about them. So standard protocols like Internet Protocol, which is called IP, and hypertext transfer protocol, which is called HTTP. Okay, these are the protocols used to transmit those data. Okay, so and is defined the structure and formation of the data packet. These two things, that's why when you want to browse, you must see HTTP. Okay, And not only you see HTTP, you must also have what we call an IP address. That is what those two things represent. Okay, so these standards are open source and are available to the public. Protecting and confidentiality, integrity, and availability of transmitted data is one of the most important responsibility of a cybersecurity professional. Now, you have now seen where your work or what you have to do or what you have to protect is. It says these standards are open source and are available to the public. Now, how do you protect it? Protecting the confidentiality, the integrity, and availability of transmitted data is one of the most important responsibilities of a cybersecurity professional. So now what they're saying is data are going to be moved, data are going to be transmitted. What is your job as a cybersecurity professional? You are to make sure you protect those files the way they are being transmitted. There is confidential, there's integrity, there's availability of this transmitted data. Okay, so we're just talking about the methods of transmitting data. So what are the challenges? What are the challenges we face? What are the challenges we face? What are the challenges we face? The protection of transmitting data is one of the most challenging jobs of a cybersecurity professional. All right, so with the growth in the mobile and wireless devices, cybersecurity professionals are responsible for protecting massive amounts of data crossing their network on a daily basis. So that is your work as a cybersecurity professional. The cybersecurity professional must deal with several challenges in protecting this data. Now, what are these data? We're talking about protecting data confidentiality. You must protect the data confidentiality. Cyber criminals are captured. So cyber criminals can capture, save, and steal data in transit. Meaning, even as your file is being moved, even as the data is being transmitted, cyber security guys can create a program that can steal. That's what they're trying to say. So cyber professional must take steps to counter this action. Then 2, protecting data integrity. Cyber criminals can intercept and alter data in transit. So cyber security professional must deploy data integrity systems that test the integrity and authenticity of transmitted data to counter these actions. Then we have the data, we have the availability, which is you must be able to protect data availability. So cyber criminals can also use rogue or unauthorized devices to interrupt data availability. So a simple mobile device can pose as a local wireless access point and trick unsuspecting users into associating with this rogue device. And when you are connected to that rogue device, all they are doing is stealing. So anywhere you see free hotspot, we always tell you, don't just rush into the free hotspot with your phone. Leave the free hotspot and let the free hotspot go. Because you connecting to that free hotspot, they have already accessed your phone, accessed every details of your phone. You don't know who owns the free hotspot, but you came into the place and you see that this is free internet, and you connect your phone into it. They've already penetrated. That's what they're trying to tell you here. So the cyber criminal can hijack an authorized connection to a protected service, or device. Network security professionals can implement what we call mutual authentication systems to counter these actions. So mutual authentication systems require the user to authenticate to the server and request the server to authenticate to the user. Now, when they create authentications like this, it helps you notice that when you connect to a particular device, they still need your permission for them to access it. That's why I always advise everybody, make sure, no matter how small your phone is, make sure you put a password on your phone. Because if you put a password on your phone, even if they have to hijack, you will have a signal that says somebody has accessed password. But if you don't have a password on your phone, and you went to connect to someone's free hotspot, and at the end of the day, they access your phone without your asking for permission or anything. That's why most times I always advise people, when you see something pop up on your phone, try and read it. Don't just click OK. A lot of us, when something just pop up on your phone, you won't even read it. You just say OK. And when you say OK, you have accepted for them to access to your phone. So it's very important. That's why they call it a phone. You have to be able to read properly before you click anything OK on your phone. Okay, very, very important. So the data in transit, this is how, challenges of protecting them. Okay, so we're going to look at forms of data processing and computation. Okay, when we get into the next class. Like I said, this class is 1 hour, and I'll be trying to see how I can increase it. But maybe by next week, by the grace of God, we'll move to our WebEx back so we can have a full 2 hours class without any interruption. All right. So the next class, we will be having the forms of data processing and computation. So we're going to understand what the thought state, what the thought state of data is when it comes to data in process. All right. It's very important. Data in process is very important. You should know how the flow of your data is being going as a cybersecurity personnel, how it's being flowed, how the flow goes. That's what we want to see. The forms of data processing and computation is what we'll be discussing in the next class. So try to join me 4 o'clock by the grace of God, so we can have the full class like I explained. Okay, so tomorrow